In this presentation, we'll get a brief introduction to the SQL select statement, as well as how to use it to perform joins. The schema that we'll be taking a look at today is in the IST210 SP 2016 database. What I'd recommend is that you connect to the LAMP server and log into MariaDB/MySQL, use the IST210 SP 2016 database, and follow along by typing in the queries that we're going to be discussing. You have access to the 4 tables we're going to be looking at today. These tables comprise a mini university registration system and are really designed for demonstration purposes. The tables are as follows: major, which stores information about specific majors; student, which stores information about students; class, which stores information about class offerings; and enrollment, which stores information about which students are enrolled in which classes. In other words, enrollment is an associative entity pulling together both student and class. Let's take a look at a very simple select example. If we want to query a table and see all of the data within, we issue a query like this: select star from student. The star, or asterisk, means you want to see every column in the table. There's no real restriction going on here. We're not specifying any criteria, we just want to see all of the records. Give this query a try and verify that you get the same results. Obviously, your results will not be formatted in the way that we see here, but you should see the same data. If we want to do a restriction, in other words, we only want to see a subset of the rows, we can specify a particular criteria to meet. In this example, we want to only see those students whose major is IST, which is major ID 1000. By saying select star from student, where major ID is equal to 1000, it will look at each record in the table and only show you the ones that have a major ID of 1000. The use of this where clause at the end of the query is how we can restrict the data to only see a subset of the rows. Give this a try. What if we want to do projection? If we say select star, what we're saying is show me all the columns. But if we want to only see specific columns, one or more, we can specify them by name. Here we're combining restrict and project by saying select and then following that with a comma-separated list of columns that we want to see. In this case, name and email. We still have to say which table we're pulling from, in this case student, and we use the where clause to do the restriction. So here we see the same 3 records, but we only see 2 columns. In other words, again, we are combining the idea of restrict, showing a subset of the rows, with project, showing a subset of the columns. Often we want to bring tables together, especially tables that have relationships. In our database here with these 4 tables, students and majors have a relationship. Each student has, within that table, a major ID. The major ID is actually a foreign key linking it back to the majors table, where major ID is the primary key. When we want to join tables together, this is one example of how we can do it. Let's say we want to see the student information, but instead of the numeric major ID, we want to actually see the major name. We would have to use a join for that. The syntax here starts with the word select, followed by a comma-separated list of fields that we want to see. Now notice here that because we're joining 2 tables together, we have to specify for each particular field or column the table in which it resides. The way we do that is we say table name dot column name. In this case, you see things like student.sid, which means pull the SID field from the student table, or major.major name, pull the major name field from the major table. After the word from, we change this slightly from what we've seen in the past. Because we're joining tables, we say student join major. The 2 tables we want to join, and in the middle we use the word join. We follow that with the word on, and then the criteria in which the records are going to be matched up. We have 2 different tables here we're trying to join. They have to merge based on a common value in a common column. So we specify the 2 columns which have to match. In this case, major ID in the student table has to match major ID in the major table. and this is the criteria which is used to perform the join. And the results that you see here are what comes out of this query. I recommend trying this query in PuTTY or Terminal, whichever you happen to be using, and verifying that you get the same results. The textbook offers an alternative syntax for doing the same thing, and really it's up to you which one you want to use. Here you see the same results with a slightly different query. What's different is what follows the word from. Instead of using the word join, you can simply comma separate the tables that you want to join together. And instead of using the word on, you can use a where clause by saying where and then student.majorID equals major.majorID. So this is a slight difference, but this is more akin to what you're going to find in your textbook. Which one you use is up to you. I will be using the explicit word join and use the word on because that's a little more standardized and a little more descriptive. However, you may use whichever version you'd like. Once we join tables together, often we may want to do a restriction of the results we get. With a select statement, whether it be a join or a simple select statement, we can always add a where clause. In this case, I'm taking the results I've gotten from the join and I'm restricting them to only show me those students who have a major ID of 4,000, which is administration of justice. Again, remember that restriction means we want to see a subset of the rows of a table. In this particular example, the join produces a table. The where clause restricts that table to only show us those records which meet a certain criteria. In this case, the major ID being 4,000. Take a moment and try this out on your own. If we look at the enrollments table, and remember the enrollments table pulls together students and classes to say which students are enrolled in which classes. If we do a simple select star from enrollment, the data that we get, while complete, isn't always descriptive. Because of the way associative entities work and ultimately implemented as tables, we have a student ID and a class ID, which are both foreign keys back to other tables, the student table and the class table. That said, they're not always the most descriptive things. So how do we make the results more meaningful? In other words, how can we see something like the student name, the class name, and the date enrolled? The way we do that is through a multi-table join. So let's take a look. Here's an example of a multi-table join performing the operation we just discussed. After the word select, we have a comma-separated list of fields that we want to see, qualified with the name of the table. But after the word from, we have three tables we want to join: enrollment, student, and class. So we say enrollment, join student, join class. After the word on, we have two criteria that have to be met. How we match enrollment with the student table, we match them up on the SID field, and how we match enrollment with the class table, we match the records up on the class ID field. And the results that we see here are the results of this three-table join. Take a moment and try this out on your own and verify that you get the same results. At this point, this is the end of our presentation. In the future, we'll get a glimpse of other SQL statements, and specifically we'll delve more into the select statement and how it can further refine the results that we get.